Welcome to your third video on practical investigations and data analysis skills development for Year 10 Science. In this video, we're going to be looking at experimental design terms. So starting off with accuracy or accurate. Now, the word accuracy refers to how close the results obtained is to the true or accepted value. Now, the true value is that would be found if the quantity could be measured perfectly. So if you could do whichever investigation you're doing absolutely perfectly, what would the true value or true result be? And then how close your value is how accurate it is. The closer to the true value, the more accurate. So if a measured value is 2.7 grams, for example, but the known value is 9.6 grams, then the measured value is inaccurate. Okay, 2.7 grams is a long way away from 9.6 grams, so it's inaccurate. The difference between the measured and the true value is what we call the measurement error. So that is accuracy. Next up, precision or precise. This refers to how closely measurements agree with each other. A set of precise measurements will have a very little variation or spread of numbers. Precision can be improved by repeating measurements and calculating an average, collecting results from other groups to use a bigger sample, and learning how to use your equipment correctly. So obviously, we can have precise values that are inaccurate. Okay, so you could have a set of precise values that are all very similar, but they're a long way off of the true value. Okay, so that's how accuracy and precision are different. We now move on to experimental uncertainty. Experimental uncertainties are present in every measurement and experiment. They cannot be eliminated, however, their effects can be minimized. Two sources of experimental uncertainty are random errors and systematic errors. So, next up, reliability. This refers to the chance that another person following the exact same method would be able to obtain the same results compared to others. Reliability is closely linked to the quality and clarity of the method and instructions. How reliable is your method to give reliable results? Okay, skipping back there, we're looking at experimental uncertainty, and we said we could have random errors and systematic errors. Okay, so random errors affects the precision of the measurements and are always present. We always have random errors. They cannot occur from estimating values using humans. They can occur from estimating values using humans to time events, not being able to read rapidly changing displays, making guesses, incorrectly using equipment, and many other sources. Okay, so you never say that it's human error. Okay, they're random errors. In the past, you may have heard the term human error, but they're random errors. Now, our systematic errors. These are errors that are built into the equipment being used or the system being utilized. So incorrectly labeled or calibrated equipment, poorly maintained equipment, misreading values because of a lack of understanding of scales, and many other sources can cause systematic errors. So it's really important that you do kind of distinguish between the random error and the systematic error. These usually cause the same amount of error and cannot be minimized by repeating measurements, because if you've got an error in the equipment that you're using, it's going to be present for all of the measurements that you take. And that is all on our experimental terminology. Rewatch that, pause it, take notes, revise that. These are very, very important terms for you. See you in the next video.